What is up, everybody? I am going to give a few more minutes before I really start proper. So, yep. Okay, just setting up my chat. As we're going, you can hit me on the live chat or on Slack. Cool. All right. Okay, well, I might as well get started. Not sure if anyone's watching yet, so you might all just be watching in the future. Let me know how that turns out. The future, I mean. So yeah, hello, Work Together friends, and tonight we're gonna start up a new quick season, and the subject I want for this season is SVG, and the goal I want for this season is everyone to make something with SVG. So I want everyone to have either a project they can put on the portfolio, something that they just think is cool. I'm gonna be I found some. This has some really cool ways of like making stuff that's actually like real live. Um, yeah. So let me get started by saying, what is SVG? What's the point of all of this? So SVG is short for scalar or for scalable vector graphic, and it is basically a way of um, describing images with code. Sounds a little bit weird. One of the cool things about it is that you could actually not write a line of code and still make SVG and interact with SVG, and like it's actually kind of cool that you don't actually need to use code to make SVG, but they are written in code. It's like in human readable code. Um, so kind of let's start talking about that. So I'm going to go to my screen, which is that one. Yeah. Okay, so go to the Wikipedia article on SVG. So yeah, this is SVG, and the idea is that here's the big distinction to know about SVG, is the difference between this and raster. So a raster image is described as basically a set of pixels, or some sort of bitmap, or some sort of dot matrix, or some sort of like, this is here, this is here, what every coordinate is, what image it has in it. And there's different variations on that, but that's the idea. Now, the thing with the raster image is that the closer you look in on it, the more it looks, pixely and blurry. And it looks good from a distance. When you get close up to it, it looks a little messed up, like a Monet painting, right? Is that Monet? No. Which one did the pointillism? I'll look at that up later. But with a vector, because we define the shapes, we can keep zooming in on these images, and they'll get more and more and more well defined. Now, I will say that these aren't, and it's not like, oh, why wouldn't we use vector for everything? Because that doesn't work well for like uh, graphic, like for pictures. Raster you'll want for that. It doesn't work very well, yeah, for those sorts of things, but they do work really well for things where there's just like a very clear shape and you can kind of zoom in forever. So yeah, there's also another few cool things. Just give me 1 second. Sorry about that. Apparently my wife did laundry and then dropped something on her foot, which is adorable. Yeah. But okay, so there is this whole vector thing. So it smooths out as we look closer into it. Very cool. Also, so not only are they're really great for icons and stuff like that, but not only is that mean that they are, scalable, it also means that instead of defining like, okay, here's this pixel and this pixel and this pixel, we can be like, okay, here's the shapes. And so SVG graphics tend to be a lot smaller. Another really, really cool aspect of this is that vector graphics, because they're code, it's easy to generate more code. Okay. So we're going to get into that a little bit and what that means. But another actually really awesome part of vector graphics, and I will be back in a second to show you a thing, but I got a cool thing to show. Hold on. Unmute. Okay, hi. So I'm going to go back to stop my presentation. Okay, so here's the other cool thing about scalable vector graphics. They're usually defined by paths, right? So we can think of these as the shapes in them, or we can actually think of them as a collection of paths, which means that that path can be given to a CNC machine of some sort. Now, a CNC is short for computer numeric control, which basically means a robot that is very tightly controlled on like how it's going to move, right? Any printer is itself a CNC machine because it's like, okay, I'm going to go here, I'm going to shoot down some ink or whatever. But when we talk about CNC machines, we're often talking about things like CNC routers and laser cutters. And laser cutters is what I wanted to point out. So this is a picture I did of my wife. Now, it basically, I took one of her wedding photos, our wedding photos, I should say, and I, I, basically pixelated it, and then with every pixel, I made it a certain, made it a circle of different radiuses, right? And then I laser cut this. So this image is actually just a sheet of black paper on top of a sheet of white paper. And what I did was I just had a laser cutter cut all those little holes into the black paper and made this. So yeah, it's actually a really kind of had a really cool effect, but was actually surprisingly easy to make in terms of the coding. So that was pretty well this turned out. It also helped that I married a pretty woman. Didn't just marry her; she was pretty. She's also like smart and nice. But yeah, here's another example I have of CNC machines. So we actually have a CNC machine in our house. It's called the Cricut. I can just show that real quick. Line. So give me a sec to share my screen. Uh, there we go. Yeah. So yeah, this is the Cricut. It is a CNC machine. So you see that basically it moves a map back and forth. and it moves a cutter or a pen or whatever back and forth. And so we have one. My wife loves using it for crafty things, and I also love using it for crafty things. So so I decided to do a little bit of like an experiment today, or yesterday kind of, where I basically created an SVG programmatically and then had a pen draw it out. So this is, now it kind of ran out of ink a little closer to this side, so this side's a little stronger. But for those of you who were in Work Together Friends a couple, I guess back in December or so, may recognize this as a dragging curve. So this is a recursive curve where kind of like it's a self-replicating fractal. And yeah, so I just created I created a program to generate an SVG of this, and then yeah, it spit this out, which is pretty cool. Another example I have, if I can figure out where I put it, because I might have mislaid it. Yes, it's basically when I was a kid, I used to do origami, and origami is the Japanese art of paper folding. Yes, I did find it. And a lot of times, what would happen is that you would make creases whose sole purpose was to help you figure out where to make the actual creases. So your paper would be covered in lines, a lot of them having nothing to do with the actual thing you wanted to make. So one of the things we can do with the Cricut is we can attach a scorer, and a scorer is just a pen that just has like a point, but it doesn't actually have an ink and it doesn't cut. It just kind of like presses down this point. And so what one of the pieces I grabbed, I found a crease pattern for was this, and it kind of folds up to be like this. This is a piece by Robert Lang, who is an amazing origami and uses computer program. Basically, I folded all the time, and then I kind of quit in high school, and then kind of quit when I was in the Air Force. And in that time, like 2001 to 2005, around there, computing caught up with origami, and math caught up with origami. And there's actually an MIT course you can get on MIT OpenCourseWare that's all about like the math of origami, and it's insane. But this is an example of being able to use a scorer to create round curves, or round kind of folds, which is, not something that's really easy to do manually. This is a pretty simple version. There's much more complex ones out there. But again, this is a thing that you could create with a program and create fairly simple if you can manipulate XML. So I want to talk for a moment before we start about XML and what it is. So go back to share my screen. And let's kind of take a look here. So this is an example of an XML. Now, it might look to you a lot like HTML, and it is a lot like HTML. In fact, JSX, the language used often for writing React, stands for JavaScript and XML. You know how if you can copy some HTML and put it into JSX, it might not work the same? That's because XML is a little stricter. But any XML, and here I'm going to create a sample.xml. Generally speaking, you're going to have a root node, right? And with any node, you can have, attributes, just like in HTML. You can have like name Jim, right? And you can have we have child nodes, a child one, right? You can have a self-closing node. And so this is kind of the basic structure of XML. About, I would say, I don't know, I want to say around kind of like 2010, around 2008, 2009, 2010, I want to say. XML was the format with which we would create, we would save files of of data, kind of like if you had like a data configuration, or you wanted to do Ajax. Ajax is short for asynchronous JavaScript and XML. The idea being that if you're transferring kind of any arbitrary data across the web, you are probably doing it in this format of XML. And in 2008, 2009, 2010, that's where JSON started kind of replacing it, because it's a little bit, it had less features and it was a lot simpler. But it, like I said, it didn't have as many features. Now, like that difference between children and attributes, it's a big difference. You know, you could have many children of the same type. You can only have one attribute of that name, and it was nice to be able to have the difference between them. I want to show for a second. So this is a book I've had for a few years as a programmer. XML Primer Plus. Apparently, this is when it's Paint, it's Primer, but when it's a book, it's Primer. I think. Pretty sure I looked that up. Yeah, and this is the size of that book. This is the intro to XML. This is the, you know, oh, here's a bird's eye view of what you can do with XML. So it is as simple as that thing you saw, but it also can get really effing crazy. You can, there's in here we include XSLT, which you can use to translate one bit of XML to a different type of XML. There is, yeah, the XML schema. There is searching using XPath and XLink. So, yeah, and I've been doing stuff with the .NET framework, and they still really use XML for a lot of their configs. Whereas, you know, when you do an NPM project, you just get, like, what I'm trying to say. If you use a project like that, you're probably only going to see like a package JSON, right? For the most part, when we have our projects, we do use JSON for that. Okay, so let me get to the actual, we'll kind of see some of the things XML does, but let's get to what we can do with SVG. So I'm going to share again. And yeah, so here's a sample XML. So let me do a sample SVG. So sample SVG, right? And what I'm going to do is I'm going to have to start with a few attributes here. So let me go back to my thing. I often just kind of copy this from MDN. So MDN SVG started. So when I'm making SVG files, I need to kind of include some of this XML stuff, which includes, it'll have a few things here. The version, which is kind of important, the base profile, and width and height. And then this XMLNS. That stands for XML namespace. And this just says, hey, this is, it kind of says this is where the standard comes from. And it kind of is like, it's also saying, it's just this really like a distinct file name. But let me take that over here. SVG. Cool, 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 cool. Now I can also create here just an index .html. This is going to, I'm just going to use this to display this particular thing. So I'm going to say image source equals a sample SVG. Okay, so this sample SVG is width 300 by height 200. I'm just going to say that I think I can. All right, let's leave that out for a second. Let's leave the background. Let's just have this SVG. So yeah, let me go to this and open it up. And now I have, well, it seems like I have a white page, but if I go down into my here, I can see my image source sample SVG. Now, how large is that? Well, 300 by 200 pixels, which is kind of what I said here. Okay, 300 by 200. Okay, so let me let's make a. If there is anyone on, which I'm not sure that there is yet, let's kind of just pick a flag, one of the simpler flags. Sorry, Brazil. Um, let's pick Romania, Romanian flag. Yeah. So it's just blue, yellow, and red. Let me also see if there's like a specific blue. Like Moldova does a 1-to-2 ratio. So this is a 2-to-3 ratio, which is what we wanted here. Okay, so what I'm going to do is I'm going to make 3, and I can use the rect tag for that. All right, so what do I have to do to use SVG rect? Take a look. So apparently I need an X and a Y and a width and a height. Seems simple. X, we're going to start with the blue. So X is Y, 0, Y, 0. The width, well, it's 1/3, so 100. And the height is 200. Okay, so let's, all right, but it's black. We want it to be blue. What can we change to make that happen? Well, I'm going to change a thing here on the element style. This is also something I could add as an attribute. But with any shape, we care about, when we're changing color, we care about 2 things, the fill and the stroke. In normal HTML, this would be background and border. Okay, so the fill here, we're going to say is blue. Doesn't seem to change that. Oh, right, because I need to actually, I can't manipulate that here. I have to manipulate it in here. So here I'm going to say fill is blue. Okay, now it's blue. It's kind of a, let me see if I can say dark blue. Yeah, that's closer to the tricolor. All right, so now I want another rectangle of yellow. Rectangle x equals, well, I guess it's going to start at 100. Y will still equal 0. Width 100. Height 200. Fill is yellow. All right. That is not the right yellow at all. Let's look at CSS yellows. So yeah, we can use the CSS colors here. 99 colors. Oh, that one's gross. Let me see. Color names. There we go. So I think like gold. That is gold is perfect. All right. Yeah, it's better. And then red. Let's just kind of make another one. As you can imagine, we're just going to say rect x equals 200, y equals 0, width equals height 200, fill is red. There's a problem, and the problem is I didn't close off this tag. Didn't know what to do with that. Let's try it again. Yeah, and there we go. Again, that red could be toned down a little bit. Let me choose a different. Do I want to go with crimson? I feel like, yeah, let's try crimson. Okay, so now we have a Romanian flag. I think there was a period of time where the Romanian flag. Now this is gonna. Oh, they had the values here. I could just use those. So let's put in those hexadecimal values. Um, now, if I remember correctly, it was 1848, United Principalities, right? And so the flag of the anti-Ceausescu protesters during the Roman Revolution was the because they had a coat. This was the flag of the Socialist Republic of Romania, and then in 1989 they put in a white circle. Basically, they cut out that seal. So let's put in to honor the history here. Let's put in that seal. So I can create a circle. This is another one of the primitives I have. Now, the circle has slightly different uh, things, though. So here's rect. There's ellipse. I could do a circle from an ellipse as well. So let's find, though, a circle. So now we have radius and cx and cy. So that's the center x and center y. So this is 300 by 200. So our center x is going to be 150. Our center y will be 100. Our radius will be 50, I want to say. Yeah. And then the color here, or fill, I should say, not color. The fill will be white. All right. Now, I wanted to include the circle for a specific reason. Now, let's say for a moment that this became a PNG, right? In fact, I'm going to see if I can save the image as. I haven't tried this yet. Oh, never mind. But it's possible to take this and save it as a PNG. Now, what I'm going to do is I'm going to take this image and I'm going to say width is 400. Okay, it's a little fast. How about 4,000? All right, now that's much. But look at that. Even though we didn't have to create a larger file, let's go to 40,000. Yeah, let's really turn this up and get our way approximately. Okay. And still, this curve is totally curvy. It's a little weird that kind of, it's a little fan out at the edges there, but yeah, I still have incredible fidelity to the original image. I feel like if I had made that doesn't matter. I was going to make it an ellipse, but this isn't the story entirely. Okay, so we have this great image. And also, by the way, the file size of this image, let's sort of reveal in Finder here. And let's get info. 361 bytes. That's it. That's as large as this file gets. It's kind of amazing, right? Like, if this were a PNG, it would be way bigger than this. In fact, what I'm going to do is I'm going to take this image. I'm going to open it up in Inkscape. Now, one of the cool things about SVG, by the way, you don't have to write code if you want to use SVG. You can use Illustrator or Inkscape. Inkscape is a free program. Yeah. All right, so this is a free program I can use to manipulate SVG. And all I'm going to do here is I'm going to export a PNG image at 300 by 200. There we go. Yeah, so it's just 300 by 296, close when exported. Yeah. So it is now exported. And this should have been. Yeah, tricolor. And the info is it is 3 times as many for the same size. Okay. Now, this isn't always the case, but it usually is. And man, this file size thing that makes it different, especially when you are trying to, when you have big photos to upload, but you want everyone to like see their icons first, like they're, the kind of icons you're going to use on that page. SVGs save you a lot of space. And again, they're really effing malleable. So, yeah. Now we've talked about the rect, we've talked about the circle. Let's take a look at some of the other shapes we have available to us. Let's talk about some of the shapes we have available to us, and then I'm going to talk about um, some of the tricks we can do. So let's go back to when we look at this one, it gave us a few that were really easy. Related topic, ellipse, image. I'm trying to use the image as much, but polygon, polyline, rect uses another story entirely. But by the way, we can also put rounded corners on our there. So let me NBN SVG. Go to the tutorial. And so some of our basic shapes include, we have rect. You can see a couple of rects here, one with rounded corners, one without. Circle, which is always a circle, but ellipse, it can be a circle, but it's doesn't exactly have to be. Both of these are, you position them by their centers. And then with circle, you just have one radius. With ellipse, you have two radiuses, right? There's a line, and there's a polyline. With the polyline, you kind of just say what the points are, right? Then there's a polygon. And again, you just have the sort of the points separated by spaces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That makes sense. That's the shape of this star here. And then you have the path. Oh my gosh, guys, the path. The path. Vectorizes stream. It looks like IKEA. The path is maybe I should stop and restart the stream. Maybe. I could at least. Mess with my display a little bit. Standard. Scaled. Okay. That is not what I wanted. Give me 1 second to. That's the one. Nope. Okay. Sorry, I was trying to fix the display, but I think I'm going to leave it as is. So, yeah. So the path is amazing. The path is like, you can do all sorts of shapes, and that's fine, but the path is where SVG really shows off. So this one gets a little more complicated. What you do is you create a D, which is kind of the D attribute is sort of the direction you're going. And what you can do is you can define kind of any shape and curve that you want, that you can imagine. So the simplest thing you can do is a line, draw a line. You can draw horizontal lines or vertical lines as well. You can, so here is drawing a, going to 1010 and then drawing a horizontal line, a vertical line, a horizontal line, and then a line to 1010, right? So you can also do curved commands, so you can define really in-depth curves. These are Bezier curves, so you have like your start, your end, and these two control points. These two control points determine how curvy your curve is, what the shape is of your curve. And yeah, and you can sort of like, I can't get into everything that's going on here, but there is a lot. Here's arcs, so if you want to do circles, you can. The arcs are a little complicated, I'm not going to lie, but they're available. So I want to show you an example of the path that I made. So this is a path. The idea here is I move to 0, 0. That should be a capital M. Capital M is move absolutely to 0, 0. A lowercase m would be move 0 over and 0 down. When you see a capital, it means absolute. Lowercase is reference for all these letters. So this says move to 0, 0, do a curve that's going to end up at 0, 100. And my control points are at 50, minus 50, 100, and 0. So I'm actually going to leave out that one. Z just says, okay, now draw a line back. So let's see that. I actually have a previewer here in my VS Code. Yeah. So the idea is that over here somewhere, there is in fact, let me draw a little circle. Circle, CX equals 50, CY equals minus 50. And then R equals 1. Let's go 2. Okay, so there's one of my control points. I have another one. Also, let me say red. And let me put another one at another point, which is, I guess, 100, 0. 100, 0. So there's these 2 points, and you can kind of see how this is sort of like, here's this little mouth, and here's these 2 points. These 2 points help determine where this should go. They kind of pull it. There's sort of the gravity that pulls it off in this direction. If I want to have the same loop on the way back, I'm going to make another curve. I'm going to make my first control point kind of the opposite where that last one was. So instead of 100, 0, it's going to be minus 100, 0. I'm going to have my next control point at the opposite of where the last one was. So instead of 50 and minus 50, it's going to be minus 50 and minus 50. And then my end is 0, 0. And there I have the other side of this heart. I actually did draw this heart out on the machine the other day, and it was cool. Okay, there's just a couple of little things I want to point out. One of them is some of the aspects you can change, like stroke and stroke width. These are, let's make that 5 actually. So these are kind of like border things. You can also change the endpoints. So there is stroke cap, which I can't really show right now because I don't have this thing. Well, let me move this to maybe 10, 0. Take out the Z, and you can see these kind of like just end in little squares. So I can say stroke line cap is round, and now they're round, which might work better for your design. I often find myself using them. Yeah. Yeah. And then you can also say if you have a corner, how sharp that corner is. Another thing we can do is we can use groups. And a group is basically, you can kind of group a few things together and then just use that group again. You can, so let me show that off. Feel like fills and strokes. Those are the fills and strokes attributes I was talking about, including dashes. And you can do something really cool with the dash, but I will get to that later. I think I'm going to save that for next time. Also, anything that you change, you can actually add as a style. This is kind of a more recent change. So I can even include CSS in. I have to do this weird C data thing because XML is weird about that sort of thing. But I can include CSS directly in my SVG image. Yeah, yeah. Then let me kind of keep on going here. Oh, and here I can link an external style sheet, which is kind of cool. Okay. We can have gradients. That's that's exactly what we have in CSS. Those are really handy. Radial gradients. Again, there are. I like these, and I want you to know these are possible, but there's some other things I want to get to real quick. Patterns. Patterns are really cool. You can define a pattern that you can use as kind of a back image, which is kind of amazing. Right. This is an important one. Text. Text I find is kind of like a tricky one. You have all this font stuff like you'd expect. What I often find is when I'm using SVG with text, I have to like center it and then kind of put it on spot. So basically, yeah, this is X and Y are usually kind of like the bottom center. So usually where I put that, and I just align it so that it's text center. That's a pretty common thing. You can also, yeah, you can define a path and then curve along a path, which is really cool. There's a lot of this, by the way, just kind of referencing, here's ID my path and href my path. So you can use those as you see fit. Transforms. Yeah. So transforms is a really great example where you can use CSS transforms just right here. Oh man, it's so useful, especially rotation. You can be doing all sorts of really cool um, animations and complex stuff. So that's really cool. Embedded SVG, I don't care about that one as much. Really hoping it gets to groups and clips and yeah, clipping and masking. This one is amazing. I just found this one recently. So a clip path is basically I define a shape and then I get to kind of take that shape out of another shape. So I could have, for instance, a series of, let me do a clip example here. Clipping.svg. By the way, clipping is also the name of a fantastic hip hop group with Daveed Diggs, who was in Hamilton, but it's another story entirely. Okay, right. So clipping. All right. What I'm going to do, I'm going to see this one. View box. That's another story entirely. But that is an important one. So I'm going to close this. I'm going to open this one off the side. Yeah. So the idea here is that I have defs. Defs is where I kind of define some things. So I'm going to, but first I'm going to make some lines. This is just going to be rectangles that are at x0, width is 200. Y, let me do one at y is 40. Height should be one there, and another one at 80. Yeah, that looks goodish so far. And then one more at 120. Okay. So now what I can do is I can make depths and and yeah, create a clip path. So let's say I'm just kind of trying to create a shape here. So what I want to do here is, I want to add an ID on this, I think. ID is circle with me. And yeah, I'm just going to say that this is a circle that has CX is 100, CY is 100, and R is 90. Sure. And here I'm going to say, let me make sure I copy this correctly. So path, yeah, equals URL circle. Yeah. I'm going to copy that to this one too. And now they kind of have this, like, they're being cut off by a shape. So that is dope. Masking, on the other hand, is like that, but you can also do a gradient. So you can kind of put shapes on top of other shapes. You can have a thing where it's like, it's mostly, you have some sort of stuff underneath it, and it's mostly black, but there's this sort of like light happening. So I'm not going to get into that one as much. It's really cool. So it's fun to use. You can embed raster images. This one's kind of like, but this one you don't get any of the benefit of raster image. So of vector images with that. Yeah. There's filter effects like blurs, but one of the things I also wanted to talk about was, I guess I talked about groups, clips, masks, and that. Yeah. All right. So it's kind of all the stuff I wanted to talk about. The next thing I want to do is just do a quick demonstration of something. So, like I said, this is just XML, which is, if you know how to manipulate HTML, is not that hard, you know? So I did a little demo that I wanted to share with you. Okay. So I made an index.js. Now this is kind of a slightly more complicated demo in terms of like some of the code complexity. So I want you to kind of, this is just me Joel Magic, as the link always calls it, and Joel Magic. So this is just me making a pattern to do that dragon curve. All right, and I used regular expressions in my route so that I could basically have this format dragon dash some number dot svg, and I could get a thing. And I also was able to get that number out. So what I did was, the part that comes back to Earth for a moment is this res.type image slash svg plus xml. This is the doc type that just says, hey, by the way, this thing I'm making is an image XML. Then I did res.render dragon svg, and then here's the data I put in, these points. Okay, so let's go on to that for a second. I also want to say here, const path d equals, so I have those points, just an array of arrays. I'm going to say, this is a polyline. This would probably work better if I made this a polyline. So I'm going to do that. I'm going to make this a polyline. Yeah. I'm going to keep all this stuff. Actually, I won't even need the fill because it's a polyline. I'm going to go back to that polyline example. Previous. Sorry about that. Text, man, text is cool. Patterns, gradients, fills and strokes, paths. Okay, so yeah, there is the polyline. So I just need the points. Fill transparent, fill none. All right, and what I'm going to have is points. Yeah. And here I'm going to say path. Right. Okay. And then here I'm going to say is points dot, I'm just going to take each point and say, because it's an array of points. So I'm going to say point dot join a space, and I'm going to take those and join them with space. Cool. So this should work as I want. Yeah, I'll get to the view box in just 1 second. So now what I'm going to do is I'm going to take this project and I'm going to serve it. Node non. I'm now listening on 3000. Dragon. I'm going to do dragon 0. See it work? Okay, so at 0, it's just one line. And you can see here I have a polyline with points of 50, minus 15 and 50. All right, cool. Now, I'm going to do 1. Okay, so now it breaks down into that shape. All right. Okay. You can start to form the curve. 3, 4, 5, 6. Yeah, so you can see this is becoming bigger and more complicated. And this, I think, not this one, it was just the next one, is the one I actually printed out on my CNC machine. But yeah, that is one of the things I can do with SVG. Let's make this. Now, I want to point out one last thing, one really important thing when you're making this, and that's the view box. You can see that the width is 500 and the height is 500, but this view box says minus 100, minus 100, 200, 200. What does that mean? Well, this basically says, hey, the top right, the top left corner, that is I basically set like a space that I'm playing with. So I say that top right corner is actually minus 100, minus 100 in my coordinate space. Oh, and the total width of my image in my coordinate space is 200, 200. So even though the image itself is 500 and 500, I'm sort of writing my points as if I have the minus 100, minus 100, 200, 200. Like I'm defining a coordinate space that I'm going to think about when I'm making my stuff. Then that is independent from the actual size of the actual image. So if it helps me to think of my image when I'm writing the code as centered at, so that 0, 0 is at the middle of the screen, I can do that. If it helps me to think of it as being really only 10 pixels across when really it's 100, I can do that. So I can basically change that coordinate space so it's like how I think of it, not how it actually gets rendered. And that is part of the fun there. But yeah, I had a lot of fun prepping this particular one. I'm really looking forward to seeing y'all. On Thursday, I will bring the Cricut, and I want to bring more pens. I hope I have more pens. I'll also bring this the following Thursday, and we can make stuff. But this coming Thursday, our challenge will be to use Express and take information coming in and use EJS to generate bespoke SVG of our own. So thank you guys for paying attention. I really appreciate it. I will talk to you later. Bye-bye.